Hey guys, this is Ife. I'm going to give a brief presentation about my project on the music personality traits derivation. Overall, the structure of this presentation will be divided into 5 main sections. They are overview, data, personality pipeline, recommender system performance evaluation, and a conclusion. Now let's get into the first part. Recently, many recommender systems use the similarity among users and items to derive the new recommendations, for example, using the nearest neighbor algorithm. However, when you first hear the word recommender system or personalization, what it comes up first is that the system uses your own past behaviors to predict your preference or user behaviors instead of using the similarity. Also, by intuition, knowing the personality could potentially increase the system's performance because it allows the systems to think in your way, then make the decision. That was the starting point for me to discover the psychological inspired recommender system. In order to do so, we need to find a media that has the potential to reveal a person's personality. And music is one of them. It could be regarded as an influencer and or a reflection of a person's personality to some degrees. Therefore, I wonder whether or not they could be combined in some ways. The overall idea of this project is to derive the insights on users' personality from their listening behaviors, group the users depending on their music preference, and evaluate the recommender system's performance among those groups of users. This project is divided into 2 main parts, the personality traits pipeline and the recommender system evaluation. Before we jump into the specific pipeline implementation and model evaluation, we first need to look at the data. On the left is a demo visualizing the dataset. For a specific user, there is or are records showing his or her interactions with a specific artist. The interaction is specified by the number of play counts. There are in total 359K unique users, 160K unique artists, and 17 million original records in the dataset. On the right is the actual dataset. Because of its large volume and relatively unorganized artist name denotation, it creates many lags during the data processing stage. For example, in the later section, Spotify API is used to get the artist genres. However, since we don't have the artist ID assigned by Spotify, only one artist is processed each time, slowing down the whole pipeline. It also shows the inconsistency between different music platforms to some extent. As for the variety, it is interdisciplinary, composed of music, psychology, and machine learning. Now it comes to the first main section. That is the personality pipeline. The goal of this pipeline is to transform the original dataset on the left to the right. At the end of the pipeline, we would get the personality attached to each user. The first step of the pipeline is to do simple data processing. Users with less than 30 rating records are dropped off in order to increase the confidence in its derived personality. With the pre-processed data, we then derive the subgenres for all unique artists in the dataset through the Spotify API. At the end of this step, the users have the profile showing in the red square. However, one issue with the utilization of Spotify API is its largely diverse genre attachment. Therefore, keyword extraction is used to map those subgenres into 11 selected genres, including jazz and pop. Then we have a total number of play counts for each 11 genres for a specific user. As for this step, the pipeline has attached each user to a rough genre preference profile. However, how could we use this information to gain insights on the user's personality? Here, we use the idea of music preference, which connect the genres with the personality. This measurement divides our 11 list of genres into four main groups. For instance, the reflective and complex music. After this step, we get the resulting scoring for each user. The reason why it does not have the personality as its final result is because of the following facts. Multiple state-of-the-art works in the music information retrieval field shows the correlation between music genres or preference and personality. The largest correlation between the music preference and personality is about 0.44. It shows that the music does provide some intuition about the personality traits of a person. However, it may only show part of it. If there is an improvement in the measurement of the music preference or there is a new music matrix, we might be able to directly use the music data to acquire personality with great confidence. However, due to the currently low correlation, it is better to stop at the stage of music preference and use them to derive further interpolation on the personality traits. For example, if user A enjoys intense and rebellious music, then it is possible for he or she to have a personality that is a combination of open, extrovert, and not easily getting nervous. Finally, after the completion of the pipeline implementation, we come to our evaluation. The goal of thus using the recommender system is to evaluate its performance among different groups of users categorized by their music preference. In here, we use one of the most popular methods used in the recommender system. That is the collaborating filtering with the alternative least square, or abbreviated as ALS algorithm. SparkML is used to set up the system and conduct the evaluation. As for the evaluation metric, NDCG, which stands for Normalized Discount Accumulated Gain and is a type of ranking metric, is used for the following reasons. First of all, we have implicit rating, which are play counts. It is difficult to use regression matrix like RMSE or classification matrix like precision for that. Also, NDCG could take the rank of the relevant item, which is the one that the user really like, into account. The closer the relevant item is recommended to the top of the list to the user, the higher of the score. Usually, the relevant score is shown as 1 or 0 for explicit rating. However, in this implicit rating setting, if a user listens to a song for multiple times, it shows that the user is interested in the music of an artist to some extent. Therefore, the strict binary setting does not work in this case. Instead, float number is assigned to the relevant score depending on the rank of the play count. Here is the result of the NDCG score for each music preference group. As you can see, there is no significant difference among all groups. However, energetic and rhythmic music group has a slightly better result for different sample sizes. The above result does not mean the actual insignificance of music preference in the recommender system. It has numerous possible causes, including insufficient data, genre profile implementation, pipeline design, etc. Based on that, here are some possible future improvements. For example, improving the pipeline design, change evaluation matrix, or change to use the explicit rating instead. Lastly, here are some learned lessons. First of all, the psychological inspired recommender system and the music preference field is still developing with many potential directions to go. While doing the project, another idea that might be more promising is to use the third-party platform to gain the personality traits or reverse the direction of the current project. That is using the recommender system to analyze the user's behavior, to draw personality traits, and then apply that knowledge in predicting the music preference instead. That's all for my presentation. Hope you enjoy it. Thank you.